Okay. We're digressing a little bit on as we've covered it, but we need to say a little bit more about it, okay? So kind of reviewing, we got H equals A times C, we want to solve for C. We can do that by dividing both sides by A. Because if we divide AC by A, we're just going to get C. We got to do that on both sides. We can't just do it on one side. So we got H over A equals AC over A. So if H is equal to AC, then when you divide H by A, you get the same thing you get if you divide AC by A. Same thing. Over here, it's numbers. It's like you have 7 equals 5C and you're trying to solve for C. You do want to divide both sides by 5. You get 7 over 5 equals 5C over 5. In other words, if 7 equals 5C, 1/5 of 7 has to equal 1/5 of 5C. Well, we do this, and formally now, as I say, people are going to want to cancel these out, but I don't like cancellation because all through, even in really the most advanced courses we teach, people still do incorrect cancellations. We want to get that straight right now, because canceling incorrectly, it's going to bite you throughout all your math courses. Okay, and to understand why you cancel. Now, the rule is you can only cancel factors. So what we do is we show that 5 is a factor of both the numerator and denominator. So we write this expression 5C over 5 is 5 over 5 times C over 1. Now that's got to be so, because when you multiply fractions, you multiply the numerator, you multiply the denominator. Well, if you multiply the numerator, you get 5C, the same as what you have here. If you multiply the denominator, you get 5 times 1 equals 5. So this is clearly equal to this. And 5 over 5 is 1, because when you divide something by itself, you get 1. And I wrote C over 1 here, just to show the fractional nature of it. And we probably want to do this until we're really clear on the way fractions work. Okay. Anyhow, you get 1 times C over 1. Now, 1 times C divided by 1 is just C, because C divided by 1 is 1. And then 1 times C is C. I'm sorry, C divided by 1 is C. And then 1 times that C is C. So this gives you C. So this is why this would justify cancellation. But I really prefer that you don't cancel. I prefer that you kind of write it out like this if you can. If you just got to cancel, go ahead. But make sure you do it right. Make sure you at least see that 5 can be factored out of the numerator and can be factored out of the denominator. So we get 5 over 5 here. And then that does give you C. And at that point, you have your solution C equals 5/7. Well, that's with numbers. Now, if you got letters, well, you do exactly the same operations. Okay, you got H over A. You got A over A times C over 1. This is the same thing as this, because this gives you A times C, which is the numerator, and A times 1, which is the denominator. It works. So H over A equals 1 times C over 1. So now you kind of reverse sides. This I give you C. Well, I'm going to write it over here. I'm going to write this side over here. Okay. So let me give you one. Let's see if we can apply this principle. Okay. You got solve that for 1. Grab a piece of scrap paper and do it in your notebook, whichever. Okay. Now this one does give people trouble, a little bit of stumbling block. So let's see what we do. By analogy, let's just see what we do if we have numbers. We have 5x plus 7 equals negative 3x plus 4. Solve this. We would want to add 3x to both sides. Which would give us 8x plus 7 equals 4. And then we want to subtract 7 from both sides. To give us 8x equals minus 3. And then we just divide both sides by 8x. By 8, and not by 8x. 8x over 8 is negative 3 over 8. So that x is, it's a little hard to read down there, it should be on the room. But x ends up being negative 3 over 8. Now the operation C is, the first thing we want to do maybe is get the x's over on one side. So how do we do that here? Right. We subtract CX from both sides. Subtracting CX leaves it to a D. And then we have what we have AX minus CX plus D. Okay, well, we've got all the x's on one side, just like we did here, right? Well, what then do we have to do? Well, that 7's over here. We need that 7 on the other side. You don't just move it. We do it by steps as you're doing. Okay. We would do the minus B equals minus B. This is a true statement. We add it to this true statement and we get AX minus CX equals B minus B. Now what do we do? This is actually the trickiest step here. Doing these steps is pretty easy to get used to. It's like what we do with numbers. But we can't just, we don't know what these numbers are, so we don't know what AX minus CX is. But we simply factor out the X. Okay, and I'll write it this way. AX minus CX is A minus C times X. Because A minus C times X is AX minus CX, right? Okay. And now what do? We divide both sides by A minus C. Now, we'll write that in another step. I don't want to, once I have this step right, I don't want to do anything with it. I'll go to another step to divide. Okay. I don't want to put this divide by A minus C here, because if I've got a mistake, I want to see one clean step at a time. It's easier to find mistakes that way. Mistakes happen. Okay. So we want to be very methodical and make sure we do one step at a time. But of course, then A minus C divided by A minus C is just 1. That gives us X. Equals this. Okay. So that's one of the things you're going to run into in the assignment. Okay, now. You need to know how to do fractions, okay? We need to know how to add them, we need to know how to multiply them, we need to know how to simplify a complex fraction, because we end up with expressions like this, okay? Now, one person did some clever stuff with a calculator, how to figure out what 7/3 minus 3 is, okay? Got a decimal approximation, I knew what the decimal equivalent was, and got the right answer, okay? And that was good, that's very clever use of the calculator, but we're not going to do that because that's not going to be helpful at all if you got something like this. Calculator's not going to help you because you don't know what X is, you don't have numbers on them. And there's some numbers in there, but the expressions themselves involve variables. And we've got to be able to do this, so we've got to be able to build a skill that allows to deal with a situation like this, okay? And the rules we use for numerical fractions are the same as the rules we use here. But again, no calculator shortcuts, okay? They're useless. Okay, they're great, if you've got fractions, fine, but no, how to do the fractions. Okay, well, anyhow, if we have this, watch what I do. Okay, fractions are a pain in the neck. Okay, they're error prone. It's much easier to make errors with fractions than it is if you're dealing with whole numbers. Okay. Okay, so what I'm going to do here is I'm going to multiply both sides. Okay, so I'm going to ask you to go ahead and simplify that. See what you get that you violated. Okay. So, okay, well, if we multiply this through. Okay. You got 24 times this plus 24 times this, right? Now, or you multiply fractions. This is why we want to write it. 24 is 24 over 1. So we see that we're multiplying numerators and we're multiplying denominators. Okay. What some people did was multiply by 24 over 24, but that's not what it says. Multiplying by 24, which is the same as 24 over 1. And when we multiply 24 over 1 times 7/3, we get 168. Well, we would get 168 over 3. But what really happens, I've been size in terms of what I saw, how we do this. This is the same as 20 over 3, 24 over 3 times 7 over 1, isn't it? I mean, the numerator is 24 times 7, the denominator is 1 times 3. Numerator is still 24 times 7, and the denominator is 3 times 1, which is the same as 1 times 3. Okay. And the bottom line of that is that gives us 8 times 7, which is going to be 56. And I'm thinking, in terms of what I saw people do, that we're going to actually do this just a little differently. Okay. Because the explanation of how you get that 8, basically 3 goes into 24 8 times. But that's not something I really want to do that. Because of some errors that are supposed to make. What I want to do, I want to start by multiplying both sides by 8. I'm not gonna multiply by 24, I'm just gonna multiply by 8. This gives me 8. Times 5/8 plus 8 times 3 equals. I can write this as 8/1 times 7/3. Okay, well, if I multiply this out, I don't like to shortcut too much, but I'm gonna write the 8 times 5/8 as 8/1 times 5/8. Okay. And 8/1 times 5/8. I don't make too many steps. I'm going to say 8/1 times 5/8 is the same as 8/8 times 5/1, and 8/8 is 1. And that gives me 5. So when you see this, you understand. I've got a 1 here and an 8 here, but I could write it as an 8 here and a 1 here. It's not going to change the denominator to put it in different order. And then I have 8/8, which is just 1. And then I see that this becomes 5x. Now, if you're taking shortcuts, it turns out that it's valid to cancel this 8 with this 8 because of this. But if you can't do this, you're never sure that you're canceling right. Okay. So you want to understand one way or another how to distinguish when you can and when you can't cancel. Okay. Now, this is going to go to 56/3. We've still got a fraction. Okay. So I multiply both sides by 3. Now, one person said, "What you got here, can't you just multiply this side by 3 and this side by 8? Okay. If the 3 wasn't there, you could. Okay. Since the 3 is there, you can't, 3 doesn't have a denominator of 8. So what we're doing is actually kind of equivalent to that, but we're actually using the rules. The rules say we can multiply both sides by the same number. The rules don't say you can cross multiply. Okay. That's a trick. It's a good trick if you know how it fits with the rules. Okay. If you try to apply it here, so we try to stick to the rules to make sure we don't make errors. Okay, well, we got this. So we're going to multiply both sides by 3. Now, I'm not going to go through all the detail I did over here to show you that 3 times 56/3 is 56. Okay, but we understand. We can look at it. I could write 3/1 times 56/3, and the 1 and the 3 could be the 3 and a 1. We'd have 3/3. Okay, so we get 56. Want to see that? Either that or you're using tricks with their own rules, okay? And that's okay too, if you get them right. Anyhow, if you multiply this out, it's clear we get 15x plus 72. So now this is easy to solve. And we never had to do anything with fractions except multiply. We didn't have to add any fractions, okay? As we would in the original. So we then subtract 72 from both sides. People like to do it this way, so we'll do it this way. Okay. And we get 15x equals 56. And then in another step, we don't combine steps. We do it in the surest possible way, which is right on every step, and don't try to do 2 things in one step. Okay. And then we get this. Of course, this can be written 15/15 times x/1. Okay, and 15/15 gives 1 and all that stuff. There's our solution. Then of course we go back and check it. I'm not gonna go through that because we're out of time. We're almost out of time. Now, what I started to do originally is I multiplied both sides by 24. Okay, well, it's the same as multiplying by 8 and then multiplying by 3. Okay. Multiply by 8, that takes care of the 8. I multiply by the 3, it takes care of the 3. If I multiply by the 24 and don't make a mistake, then what I end up with is going to be this equation, okay? So we can more quickly end up with this and multiply by 24. But I prefer that we don't get in a hurry. If we get in a hurry, we don't necessarily see every step as clearly as we need to see it. And if we don't write out every step, we aren't reinforcing the rules, okay? And we need to do that. We need to get nice and precise. Okay.